Welcome everyone to the 2025 AAA Online Forum on Climate Change Technologies, and we thank everyone for participating. As a reminder, we encourage everyone to submit their questions to and comments to the Zoom chat box. And today is the third and last talk by Dr. Prathna, and she's a implementation lead with the Foundation of Resilience Actions in Hyderabad, in India. And Prathna has extensive experience in addressing urban water challenges in India. So, with this brief introduction, I'm inviting Dr. Prathna to deliver the talk with a brief introduction about herself. Dr. Prathna?
Thank you so much, Dayalan. Thank you for so much for the brief introduction. Good morning, good afternoon, and good evening to everyone who've joined from whichever part of the world. I'll just start with a very brief self-introduction. Yes, like Dayalan had mentioned, so I currently work with the Foundation for Resilience Actions. So my stint with climate change and climate change adaptation actually started maybe 7-8 years back when I actually got a chance to work in the Delhi government, India. So I worked with the water utilities there called the Delhi Jal Board, Jal meaning water. So that was the time I started working on restoration of water bodies in Delhi. Further to that, I was also working with Wetlands International South Asia. So this is where I got introduced to the concept of wetlands and how do we look at ways in which we can manage wetlands in India. So more recently, for the last nearly 4 years, I was working with the World Resources Institute in Delhi, wherein I primarily worked on a project in which we worked with two vulnerable communities in Delhi, and we basically looked at improving their water security. This was an eye opener for me working with communities, and more recently, I'm working with the Foundation for Resilience Action. I will now directly jump into my presentation. So, the topic I have today is on unlocking climate change adaptation. This is more specifically from a water perspective. I'm just gonna be sharing the experiences that I've picked along the way, primarily working in Delhi. And this image here that I'm showing is actually from the floods in Mumbai. This was sometime this year. So I'm just gonna start with this image and moving on to why we talk about climate change a lot nowadays. So I'm just starting with a very brief introduction on how is climate change affecting us. It gives us extreme rainfall. You have a lot of extreme rainfall events. You also have a lot of droughts, desertification. It in an urban setup, it also leads to an urban heat island effect. So when I say an urban heat island effect, it's basically urbanization with a lot of concretization, a very little green cover. And when you in these places, when you have a lot of desertification or droughts, it increases your microclimate in this region. So it also increases the heat stress in a region and also leads to frequent landslides. When I am primarily talking from an Indian perspective, how is climate change affecting India? Not surprisingly, India is the third most disaster prone country in the world, and with 2% of the GDP loss happening due to natural disasters. So, here, if you'll see, there are two maps of India. So, one between 1991 to 2000, and the other one from 2011 to 2021. So, if you will see in certain places, maybe more specifically, if I'll just want to, okay, I'm not really sure how I can show my pointer, but towards the southern part of India, so there is this state called Tamil Nadu. So Tamil Nadu is a state I come from. So if you will see between until 2000, this was a place that was frequented a lot by cyclones. But if you will see between 2011 to 2021, so this same place now frequented by a lot of floods. So actually every year, so Tamil Nadu is a place which faces flood. So the climate change is actually impacting us in many ways. So places which did not have, say, for example, landslides before. So towards the northern part of India, so this was not a place which used to have landslides before. It was frequented by floods. But in the more recent years, Himachal Pradesh and Uttarakhand, say for example, you get a lot of landslides. So the topography is changing. The way climate change is impacting different states is different. So you do need you need to look at ways in which you can adapt to this, look at mitigation through other ways, but also look at adaptation. So the previous slide I told that this is actually increasing, losing, leading us to lose 2% of our GDP. So 1.5 million people have actually been displaced because of climate change over the last 5 years in India, which is an alarming situation. So I think nowadays we hear a lot about these terms: mitigation, adaptation, climate resilience. So in a very way, how do we explain this? So mitigation and adaptation are actually complementary ways in which you can actually move towards you can better adapt to climate change, or you can actually move towards a more resilient community or a country, say for example. So when I say mitigation, so these are actions that you take or to reduce or even remove the cause of the climate change that's happening. So say for example, we moving more towards renewable energy, and we also moving towards more sustainable transportation as an example. But then when I talk about adaptation, it is how do you react or how do you respond to climate change, which is a reality. So you move towards more infrastructural upgrades which are resilient to climate change. You also look towards more of flood protection. So these two things actually help in a country or a state work towards a resilient community or a state. So I'm now gonna jump more directly to the connect that it has with water. So when we talk about climate change, so there is another concept which is urbanization, which is very closely linked. Both terms are very closely linked, and I'm just gonna look at the intersection of what climate change in the next 2-3 slides. So the consequences because of rapid urbanization or unplanned urbanization, which is something which still happens in certain pockets there, are three. So one thing is it leads to too dirty water. So this is an image actually during one of the site visits in Punjab. So this is too dirty water. So with rampant urbanization and when it's actually more unplanned, you are the country or the state is actually not prepared to all the waste, that is wastewater that's getting generated. So you are not in a position to actually channelize all the wastewater through centralized sewer networks and take it for treatment. So you end up with too dirty water. Too much water. So climate change together with urbanization is also leading to this a problem of too much water with too frequent flooding events and with water having no way to go because of extreme rainfall events. You also have challenges of too little water, drought-like situations during the summer months when there is water scarcity. You have many places in India in which people fight for the basic right of water, water supplied through tankers and other means, and this is definitely a challenge. So the next slide, so we actually understood what are the primary challenges of climate change, water, and urbanization, the interconnect. So what are the possible steps that you can look at from a climate change adaptation perspective? So ideally, when you want to move towards climate change adaptation, you start with planning. So I talk about, so how do you incorporate concepts which can actually help towards move towards climate change adaptation? Are you going to come up with new policies, new missions, or are these interventions going to be incorporated in your master plans for the city? Or the second one is more on data-based decision making. So data plays a very integral and a very critical role. So data in the form of remote sensing, GIS, can actually help better respond to natural disasters because of climate change. The third one is once you have the data and once you have the evidence, what is it that you're going to implement to see that the city or the state is better adapted to climate change? So this would be towards moving towards implementation. So this is more on climate resilient infrastructure. So this could be in the form of nature-based solutions, water sensitive urban design, integrated water resources management, looking at more water reuse concepts, and also looking at smart water metering and things like that. So the next concept that we can actually look at is, so we have built infrastructure. So what are the different ways in which financing can be obtained? So could this be through government budgets, or could this be through external funding, or could this be through different models like a public-private partnership? And the last part, which is a very critical part, is more on the operation and maintenance. Once you've implemented infrastructure, what are the things that you can do to see that any of the solutions that you've implemented are sustainable, and everyone has an ownership on maintaining the infrastructure. So I'm just, in the following slides, I'm just going to describe each of these in a little bit more detail. So with the first one, which was on missions and agencies. So this slide here, I'm not going to delve a lot into it. So for India, there are a number of policies and number of agencies which are there at the national level, at the state level, and also at the city level. So I'm just going to start with the national level. So one of the most important action plans that are there at the national level is the National Action Plan for Climate Change. Just going to give a little bit more details on this action plan in the next slide. So we also have certain agencies. One that I like to call out here is the National Institute of Urban Affairs is one of the agencies. So here they have a center specifically for climate center for cities. So they work very closely with different states and cities to formulate their own action plans. So to help any state or any city which is experiencing natural disasters, you also have the NDMA, which is actually called the National Disaster Management Authority. You also have a disaster management authority at the state level. So when it comes to a state level, you have different state environmental departments, which also make the state action plans for climate change. And so when I go to at a city level, more at a city level, there is one mission I'd like to mention here, which is the Atal Mission for Rejuvenation and Urban Transformation. So this mission actually looks at implementation projects which work towards urban transformation. So say, for example, restoration of water bodies. So there's also one campaign which is Race to Zero. So this is a United Nations based campaign. And through this campaign, United Nations works very closely with city authorities to see that these city authorities also help, help in implementation or in policies, which can then help the government at the center to move more towards mitigation and actually moving more towards achieving the targets that are set, like reduction in carbon emissions, for example. So a little bit more on, okay, I think this slide has just changed a bit, but nevertheless, so there is, at a state level, there is a state action plan on climate change, which was something that I just mentioned in the previous slide. So in 2009 was when we had the National Action Plan on Climate Change, which was formed at the national level. So through this action plan, the government of India directed all the state governments and union territories to make action plans on climate change, for which you also have some agencies which help different state governments and cities to make their action plans. So the focus area is on the following topics that are shown in the right part of the slide. So water being one of them. So so I just mentioned about a city level action plan. So this is just an example of different action plans that are being made by different cities to move more towards climate adaptation and being more resilient. So the second point that we had mentioned in the previous slide was more on the importance of database decision making. I'm just going to show one example here. So I'm just taking the example of the city of Bengaluru. So Bengaluru is a city, it is in the southern part of India. So this is a rapidly urbanizing city, if I can put it that way. When there was a study done to see the groundwater recharge potential, so we found out that 85% of the floodplains in Bengaluru were encroached, or they were actually built upon. So with urbanization and climate change, there is a lot of rains that keep happening. So because of which there are certain places. So this is actually one example for from a place called somewhere near Bellandur. So if you can also see the maps the difference in the years, the watershed is actually encroached with water having no way to go. it is not actually reaching the water body. So you actually have flooded streets, even with a small shower. So now I just move to the next part, which is once planning is done, there are missions in place, and you have that is generating from GIS and remote sensing and other data that you collect from the ground. I think we should now talk about, once this is done, what next? It's more on moving towards climate resilient infrastructure. Do we need to have new climate resilient infrastructure? Of course, yes, because for India, at least 75% of the infrastructure for 2050 is yet to be built. So we still have the opportunity to do that. So when we talk about the climate resilient infrastructure, this map here, it actually shows that among class 1 cities, at least 271 class 1 cities are still prone to floods. And primarily this is because of rampant concretization of natural landscapes. So flooding is something that happens every year. So when it comes to solutioning, there can be different ways in which we look at solutioning. Something that's commonly talked about is using nature-based solutions, and also water-sensitive urban design. So this is nothing but actually it's more of a spawn city concept, in which we use natural solutions to then combat or adapt to climate change. So say for example here, so this image here, I had talked about the challenges, the interconnect between climate change, urbanization, and water. There's either too much water, or there's either too little water, or there's either too dirty water. So how do we actually look at solutioning here? So when we actually have some green belts or rain gardens, so this is greenery which can actually soak up a lot of rainwater, and this can then be taken into stormwater drains. You slow the flow of the stormwater so it doesn't flood your city immediately, and you can also actually have it as an underground storage tank, and then it is slowly released when it is needed. So you can actually go in for concepts like porous pavements wherever it is feasible, and you can also go for concepts like green roofing, green walling, which play a very integral role in reducing your urban heat island effect. So there are other ways in which you can also go in for recharge pits, and which actually improves your groundwater recharge. You can also go in for a lot of constructed wetland systems, which also then improve your water quality. And so this is more of a solution towards too dirty water. So this is just a conceptual diagram. I'm just going to explain it with some examples. So the examples I have here, so before I move on to case study, so I would like to talk a little bit more on my experience of having worked in a different kind of projects and our learnings from that. So initially when I joined the sector, so my thought process was maybe if there is one solution, I can actually use it for all places. So that was the idea that I came up with. But once I started getting implementation and then having different stakeholders, it was more of an experience. I'm just going to start with the first study. So this is one project which is very, very close to my heart. So this is a project from Delhi, so this project is on the restoration of a water body. So this was among the first projects I started to work with when it came to climate change adaptation. So the name of the water body is called Rajokri. So I am just going to some details about it. So Rajokri is basically located in the Delhi NCR region. NCR is a National Capital Territory region. So this is just bordering, and it's more a semi-urban area. It's not a city. And the problems of this area, so it's more a semi-urban settlement that was there. They did not have centralized sewer network. So while I was part of the Delhi government, so there were two ways in which we could go ahead. So either we go for connecting this area with a centralized sewer network, or we look at a decentralized model. So this area was actually, this water body, the existing water body was actually unused. So it had a thick layer of sludge because of sewage that was actually flowing from different places, and it found its way into this natural water body. And because there was a thick layer of sludge, there was no groundwater recharge that was happening. And because of this, this area was also a breeding ground for mosquitoes. So this was more of also a health hazard for the community living there. This was a time that we actually thought we should go ahead with a decentralized model, because also considering, because this area did not have a centralized sewer network, did not have trunk sewers, it did not have also other connecting sewers, the peripheral sewers. So the entire cost of connecting this area with a centralized sewage treatment plant was going to be a lot. And it also didn't solve the purpose, because during even small flooding events, this area used to get flooded a lot. And with the thick layer of sludge, water did not even get inside, and there was no groundwater recharge happening. So to tackle both of these problems, we went for a decentralized model. One significant thing here is, if you will see, there is hardly any operation and maintenance cost that I've mentioned here, the OPEX, which was negligible in the intervention. So I'm just going to give more details about it in these slides. So if you'll see the image at the top, so this is how the water body was previously before we initiated work. And the second image is after the water body was restored. I have a more clear image towards the end, which I'll show you. So what were the interventions that we went ahead with? So it started with desilting of the water body, and the thick layer of sludge that was there at the bottom was removed. And so this also increased the water holding capacity of the water body. The interventions done here, this was primarily nature-based solutions. So the technology that we actually used here, we call it the SWAB, which is the scientific wetland system with an active biodigester. So there were two types of treatments that were used. One was a constructed wetland system. The other one was, the primary treatment was more on using a biodigester to actually reduce the pollutant load. So as a tertiary treatment system, we also had floating wetlands. And further to that, we improvised it with using a carbon filter and a sand filter before this water was then let into the water body. So there were other concepts that we used, where nature-based solutions, bioscience, level pathways that were there to increase also the groundwater recharge in the area, and also channelize the water into the water body, the rainwater. There were other bioremediation grasses that were also planted along the walkway to also see that there is water purification always happening. So there were other allied interventions that we carried out, which I will specifically mention in the next slide. So if you'll see the last point here, we also had an allied intervention. This was a space for conducting Chhat Puja. So I'm just gonna mention what this is. So the first image that you will see, you can see something like a amphitheater that is there. This part of India, so this specific part of Delhi, they also celebrate a festival called Chhat Puja. This Chhat Puja is actually celebrated where people from the community, they pray, they worship the sun standing in water during specific times in a year. But this is actually not common to all places in India. So this is one specific community from one specific state who celebrate this. So when we actually started intervention, so one thing that we understood was the community was not receptive, or they weren't happy with the intervention, because for them, it was more on, is this place going to be turned into something else, or is this place going to be taken away from us? So that was a thought process that they had. So they weren't very receptive, but then it's the government doing it. So the government goes ahead and does interventions. So once the interventions, the construction actually started, there were also engagements that were happening parallelly with the community. So that's when we also realized that there is this festival that the community celebrates. So why not make some, also incorporating the social and the cultural, practices that the community has. So would that actually help in building trust? And yes, it did. So once we started incorporating that into the design, the community did come in, and they were all the more excited to be part of the process. So this is one learning that we had. Always keep your ears to the ground to see How well is the uptake of any intervention that you're doing, because we are looking at sustainability of solutions. So this is an image that I would actually like to show. This is a drone image that we have of the restored water body. So here you can actually clearly see the amphitheater that we create for the community to take part in cultural events. So we made sure that whenever this festival was happening, post the festival, this water doesn't reach water body that's restored, because there's also a lot of flowers that are offered. So we made sure that it's a separate area which is filled with water just for the festival, and then the water is emptied and it doesn't reach the water body. You can also actually see the treatment system here towards the end. I'm not really sure if I can keep my pointers. 1 minute, I think I can. So if you can see my pointer here, so this is Dayalan, I'm not really sure. Is this my pointer? Can one see my pointer?
Yes, I can see that. Yes.
Okay. So the area that I'm actually showing here is the constructed wetland system that we had. So this again has a lot of wetland plants that grow. So it actually doesn't look like a treatment system, and treatment actually happens underground. And this treatment system also runs fully on solar power. And so we had solar cells that are here. And so this is the amphitheater I was talking, and these are floating wetlands that you can see, which also look at continuous purification of the water. And the operation and maintenance is very minimal. You just need someone who doesn't even have to be technically inclined. So this is basically on replacing the wetland plants and nothing else. So this was one of my the projects that is very, very close to my heart, and this was the first project I worked with. I'm just gonna very quickly move to the next case study. So the idea behind okay, so the idea behind showing different case studies is basically, I think um, it's like basically to cement that every project is different, and you really have to tweak it depending on existing conditions, and also depending on what other stakeholders want as well, because at the end of the day, we are looking at sustainability of solutions. So this second project that I'm going to talk about is, I mean, I don't have many slides on this. So this project was actually captured in the newspaper article. So this was sometime in 2019, and it's also captured in a Brute India video. So this was again a treatment system that we piloted while I was working in the Delhi government, working very closely with my boss, who's mentioned here, Ankit Srivastava. So this was a pilot project that was tried to purify drain water. So this was nothing. This was a plug and play system. So the problem that we had in this area, so this was somewhere very close to the office that we were working from. So there was a very big drain. So this drain is actually called the Shadra Link Drain, which actually ultimately reaches the river Yamuna. So this drain carried a lot of sewage water. The pollutant load in the sewage water was a lot. And so one way to do this was actually have a new sewage treatment, a centralized sewage treatment plant, which could then take this water. It would definitely take a lot of time, and it would take a lot of money. So our idea here was to test different technologies to see if it can take the pollutant load. The pollutant load here was heavy. So we piloted two treatment systems. So one was the electrocoagulation system, and one more was to test the efficacy of geotubes and geotextiles. Yeah. So, and the other concept that we actually wanted to demonstrate here was you don't have to purify water everywhere to drinkable standards. So say for example, so this area did not have land availability. So land availability was a constraint. So went for a plug and play system. So which that this system could be taken anywhere where it was needed. You just had to assemble the technology and take it anywhere where it needed. So wherever there is a land constraint or you have issues with land ownership, so this is something that can definitely be tried in a developing world. So the cost of treatment, what we understood here was the cost of treatment was definitely higher than the previous model that I had showed. So the previous model wherein the water body was restored, So this was that was actually less than one. Sorry, that was less than 1 rupee per kiloliter. But here, this is actually a little bit more than 1 rupee per kiloliter. And So we showed three levels of purification here. So not all water has to be drinkable, as I mentioned. So if it was used for a horticultural purpose, you didn't have to go for a lot of treatment technologies. You could treat it to a certain extent, and that could be used for horticulture, because water that has a certain amount of nitrates and phosphates is definitely good for plants. If you're using it for drinking purposes, you also need to then go for further treatment like a UV treatment or also an RO treatment. So this was a concept. So depending on what the end use of water was, your treatment system could actually just cater to that. So that was a concept we wanted to show here. So also the choice that we made was, if there is land availability, you can always go for a constructed wetland system. And also if the pollutant load was lesser, a nature-based solution definitely works. But in a city like Delhi, in a country like India, not all cases a nature-based solution works. So you might have to go for a hybrid treatment system. So nature-based solutions can always be there, but it is an add-on to a chemical-based or a physical-based. So that was learning. So the third case study that I'm actually gonna tell here is again from Delhi. And so this is from my project while I was working in World Resources Institute. So this was one of the sites I got a chance to work with. And this was again a project wherein I very closely worked with communities, vulnerable communities as well. So this is actually, these are images from a pocket park in one of the site locations. I don't think it makes much sense to tell the name of the location. So this is a park, and when it rains, the park gets flooded, and it takes at least a week for the water to drain out, because the sloping was different. Water could not find its way outside. Groundwater recharge wasn't happening. And so this was actually 1 week after the rains, and this is how it looked. So very sludgy. And this was an issue that was also becoming a health hazard for people there. So this is how we started working with. So initially, we were actually looking at different concepts on how was it that we could look at when it comes to restoring the park. So we started with capacity building of the community. So this was more on sensitization, um, asking from the community. So do they understand the impacts of climate change? Is this something they would want to work on? And then building their knowledge on climate change and why do we need to adapt ours to it. We also had community mapping exercises in which we worked very closely with the community to understand their priorities and their asks. So we also, through sensitization, we looped in the community members for waste collection drives in the park to, bring that sense of ownership to them, that, the park belongs to them as well. And this is a place where it could be a healthy, livable spaces if maintained well. After that is when we started a greening initiative. So when I tell it's a greening initiative, so this place hardly had any green cover when it started, except for the natural lawns that were there in the center. But other than that, we did not have much greenery here. So then the idea was, can we then look at plantation of native species? Is that something that the community would want? We were also actually exploring other technologies through the project, so more on water sensitive urban design. If we could actually try wicking lawns. So wicking lawns is for most of you, for some of you who might not know, wicking lawns is actually a concept in which you have an underground storage system which takes in rainwater, and then it slowly releases through a capillary action. The water is released and it helps in growing lawns, maybe not specifically plants, but more effective in lawns. And it is used more frequently in other developed countries here. Maintenance does take time, and it also comes with challenges, because there could be salt deposition and so on and so forth. So there were some concepts through the project we were trying to check if that's feasible. So when we went to the officials here, the government officials, the government stakeholders here to discuss the different designs that we had in mind. So one thing actually came across. They actually told that if the community is involved in operation and maintenance of the restored water body, that's the restored park, that is when the model succeeds. And the more complicated your innovation is, the more difficult it is for anyone, be it a government official or even a community member, to then look at operation and maintenance. So the ask was, keep it simple so that it's sustainable. So this was definitely a learning for us. So we also went ahead with exercises, community trust building exercises, like a tree census, in which the community were sensitized to actually look at the local tree species, the plant species that they have in their community, look at the health of each and every tree that they have. So this was more on them sensitized. And when it came to the conversations on operation and maintenance, so one thing that actually came through was, a learning that came for us was, the primary needs of the community were water and sanitation, providing drinking water and then providing sanitation. So if those asks are satisfied, that is when they actually think about next one, which is more on, providing water for plants, having a clean livable spaces, because your basic needs are then met already. So through this project, then we went ahead with establishing community water forums in the community. So this was a forum in which the community members, as well as the local government stakeholders who are in charge of the maintenance of services, they have conversations. They come, they discuss, and they sort out any issues and challenges that they have, and they work together. So this was a water forum that we established through our project. And then we found out that it was more of a trust building, both for the government officials as well as the community. So this was more on the community also taking ownership, and the concept that we call here is joint accountability. So that was a learning, and that was something that we could get through the project. So this is one of the images of the restored park. So we actually made it a barrier-free park, which was more towards universal accessibility. So people with disabilities could access this park as well. So again, few images on, we did not want to go towards more complicated innovations here. We went ahead with very simple interventions, more of looking at simple recharge pits. So we found out the slope in the park, went ahead with very simple recharge pits, which had gravel, pebbles, and that were lined with geotextiles. The community, people from the community were then involved in the construction activities. So if you'll see the first image, that's again a woman from the community. The second one is kids were really excited to also be part of, in the greening activity. So the plants that you see around the recharge pit. So the second one is more of a recharge pit once it's been filled. So it's I don't know what is the common name, but the scientific name is vetiveria. So we planted vetiveria because it has its capacity to also survive when there is hardly any water, and its root system is it's known, it's a medicinal plant, as well as it is known for its root system, which can actually keep the recharge pits more intact. It's a very strong root system that it has. The third one is again involving women from the community for the plantation drive. So these were the learnings from this the third project, and I am just gonna end with this slide, and I'd like to have a discussion session after that. So these are images from today. So I'm currently in Sundarbans for a site visit. So Sundarbans is actually located in the state of West Bengal, and this is an area which is pretty frequented by cyclones. So Sundarbans is also a Ramsar site. Part of it is a natural reserve. It is known for the Royal Bengal tiger as well as its mangroves. Part of it is in India and part of it is in Bangladesh, to just give a context. So this area it's a very beautiful place. It's more of a rural setup. But the thing is, this area over the years is affected by salinity, saline ingression. You have, because of climate change, you have a lot of frequent cyclones that happen. So when cyclones happen, so what happens is it actually brings in a lot of, the seawater. into the land, as well as it also leads to saline water intrusion, ingression. It is contaminating the groundwater. The surface water is also contaminated. And the other thing is you also have issues here with, because of frequent cyclones. You also have this area also doesn't have a regular electricity supply, so you have a lot of fluctuations in electricity. Certain places do have reverse osmosis systems, centralized, not centralized, but more from each village. Few villages do have RO system, but the problem here is um, pretty different, because you do not have a constant electricity supply. It's also an issue operating and maintaining a membrane based system. And when the water is really saline, it complicates the issue further, because you need to frequently change your membranes if you're going for an RO system. And at least from the site visits I had today, one thing that we could observe was most of the households where, so the first image is actually a tube well. So this is basically tapping into the aquifer, taking the water, and it doesn't have any treatment system. People just collected bottles and they consume it. And we did water quality analysis today. So one thing we found out was, yes, the water is pretty saline here. Possibly it has other contaminants as well, and the TDS was pretty high. Each and at least almost each and every household, they do have they do have ponds just next to them. So it's more of private ownership of the ponds. So the second image is a pond, and this is just next to, it's one household's pond. So what they do here is they generally breed fish, and this fish is for personal consumption, which is still fine. But in addition to it, what happens is, in most cases, people also use this water for bathing. So they bathe in this water. So this image is actually at least brownish in color, but the water is brownish. But in most cases, I could also see algae-based water. People bathe in it. People wash dishes in it, and it's for almost all purposes except for drinking. For drinking, they do depend on hand pumps, which is again polluted water. So this is the unique alarming situation here in this area. So the solution that I might have for a city like Delhi will definitely not work in a place like Sundarbans. So Sundarbans problems are unique, definitely compounded by climate change. And so you would need unique solutions which can actually help them with, so drinking water is an issue. You would definitely have to come up with solutions. The agricultural produce is also affected, because saline intrusion and the salt that's getting deposited from cyclones, it creates topsoil area, which makes it more saline, and it's actually difficult for them to then even grow crops. So climate change is a real problem here. And what is it we can do? So, I mean, a typical RO system might not work, um, because you would then have to look at other ways, maybe look at renewable energy, because you just cannot depend on the grid for continuous supply of water. And you also need to make sure that the infrastructure that you have is also resilient to climate change. So is it rust proof? Is it on a pedestal or a high platform, so that it's a bit more resistant to cyclones? Or is there some other way you can better it? So someone who visits this area would actually have an understanding of how difficult it is to provide a solutioning here, or what are the other challenges you might want to look at. So um, so here, this is definitely not an area where you can actually go and just tell talk about renewable energy, say for example, because for basic needs not met. Is there clean drinking water yet? No. People falling sick frequently? Yes. So I just wanted to end this slide telling, like, when it comes to solutioning, we basically do not have a magic bullet, which a solution that works in one place, it might or might not work in a different place. So I would actually put that as an opportunity. So this is my conclusion slide. So what do we see as opportunities? So definitely, when we talk about India, there are definite enough policies and missions are in place. And there is definitely an effort to move more towards climate resilience. And so the actions are more towards adaptation as well as mitigation. So diversity, I mean, I have just described experiences from two places. So one primarily from Delhi, and even within Delhi, we could actually see that the diversity is immense. So the diversity in the country is actually immense. So urbanization is definitely, compounding the effects of climate change. So one solution that might work in one place of India might not work in other place of India. And whenever we think about solutioning or installation, think operation and maintenance of it. The more simpler the operation and maintenance of it, the more successful you can actually look at the sustainability of the solutions. And at least in this case, it's definitely very important that communities are they have the full buy-in, and it's joint accountability, having those sensitization training capacity building sessions to actually get that sense of ownership. Because from experience I can actually say that it's totally different when you work with very vulnerable communities, because their priorities are totally different. So their basic needs are still not met. So when their basic needs are met, are when they actually think about climate change, or what is it that you actually have to work towards to getting a healthy livable space, for example. So when your basic needs are not met, so you actually do not think about those things, and rightly so. But then if you also get a chance to work with another setup, another community which is better educated, or they have access to better education, better jobs, right? So then they think about a water body restoration. They actually commit to operation and maintenance of a water body. I mean, this is something from an experience I actually talk. The buy-in is actually more easier with those communities. So you actually need to have your ears to the ground, listen to what the priorities are and what the needs are of the community, and as well as the local government agency, because they work there for long, to then go ahead with any installation or any implementation, and make sure that if there is so I've worked in the government. I've also had a chance to work with a not-for-profit, and now as a funder. So we do understand that the needs, the priorities are totally different for each and every community and each and every stakeholder. So just keeping our ears to the ground to then looking at sustainability of solutions. So I think I'll just stop here and like to take questions.
Thank you, Prathna, for the wonderful talk. And the projects, case studies you mentioned are very impactful. And I'm sure the attendees would have benefited with your groundworks. We have some questions to take. I think I'll start from the last question from Charlie. From last, I'll go from the previous questions. In India, are wetland areas being destroyed for other uses? In the USA, many wetlands have been destroyed, and there are efforts to bring them back.
Yeah. Thanks a lot for the question, Charlie. Actually, the situation, if you'll ask me the situation 10 years back, definitely I would say that wetlands were getting, taken up for other purposes. But more recently, over the years, at least the last decade, I would say there's been more work towards management of existing wetlands, mapping them as Ramsar sites, and also then when you map a particular wetland as a Ramsar site, or it is under a protected area, so managing it is then better. So then it is actually not lost to encroachment. So there is a ministry, which is the Ministry of Environment, Forest and Climate Change, which is actively looking towards management of Ramsar sites and wetlands. So over the last 4-5 years, I think in Asia, India is the country which has a maximum number of Ramsar sites which have been designated. So when you designate a site as a Ramsar site, so then it then guidelines, the protection, the legal protection is better. So you can actually not very easily encroach it. There is still some that is happening, but with directives that are coming from the ministry, uh, most of the states in India are also establishing state wetland management authorities at a state level, which looks towards sustainable management. Of course, it's definitely a long way to go, but I can positively say that maybe there is definitely progress that is happening here in this.
Sure, thanks. Um, The next question from Charlie as well, related to wetland. I think, um, did you make the wetland flotation devices? Are they available from the manufacturers?
Okay, yeah. Thanks, Charlie, again. So this one that we actually did was an assembled device. You actually get it readily available as well. There are many vendors who do it. But in our case, what we did was, in most cases, I would say, people use PVC pipes as for the floating wetlands, which is definitely not a good solution. So in our case, we assembled the floating wetlands, or we also call it the floating rafters. And the plants that we used in these floating wetlands were actually, so because the pollutant load is still there, there's still minimal amount of pollutant load, and we also wanted plants to survive longer in the water. So what we did was we had the root system treated with specific microbes, which actually take up a lot of the pollutants that were there still there in the water, to ensure that the survival rate of the plants is better, as well as the continuous treatment of water keeps happening. So to answer, yes, to answer your question, we assembled it, even though there are options to definitely purchase it.
Thanks, Prathna. I think and related to that question is, do birds use them, the floating devices?
So the floating wetlands, the floating devices that we had here were pretty small. So we have 17 and till. We did not. We did see a very few birds during. During the migratory period, which is December and January, there were few birds that came, but most of the birds that we found were not on the floating wetlands, but more on the trees. So that was something that we observed, but not much. But I've actually looked at other case studies that have been done in other parts of India as well, wherein they make these birding islands. So instead of the floating wetland, here the area that we had, the water body itself in itself was very small, so we couldn't go for a birding island. But in general, the model that's used mostly in India is you make different birding islands. So birds do come for nesting, breeding, and then they go in these birding islands. Yeah.
Thanks, Prathna. The next question from Ron, I think she's asking for coastal areas, where does the sea level rise come into play? What dimensions are projected in planning horizons?
Okay, I am not really sure if I can do justice to this question, but I'll just try to answer it to the best I can. So I'll just like to talk about my experience. So I worked with mangroves, so both in the western part of India and in the eastern part of India. Not extensively, but maybe roughly 6 months. And more recently with Sundarbans is, I mean, today was my first day in the site, also looking at the mangroves. So the tidal interplay is pretty different in the western coast as well as in the eastern coast, just from my brief experience that I have. So I have had a chance to work in Mumbai, which has a lot of mangrove cover. So you see that the tidal interplay is quite a lot. The tidal intermix is quite a lot in the western part, and the mangroves, the growth of mangroves is really good, really growth good, and it doesn't have stunted growth. And I also had a chance to work in the eastern coast of India along Chennai. So Chennai was actually a city which had tsunami, if I'm right, some 20 years back or maybe some 15 years back. Post which there was, more initiatives that the state government took towards building these. They call it the sea barriers, or they also call it the bioshield. So that's a concept or the term that's used. But if you will see the mangroves primarily in Chennai, so the tidal interplay is very less. So the fresh water and also the salt water mix is not so much. So you see the mangroves here very stunted, unlike the ones in the western coast. And sea level rise is definitely, I mean, the dimensions, I might not be the right person to tell that. But the sea level rise is something that's actually being witnessed along the coastal regions, entire coastal regions of India. And there is seawater ingression that's actually happening, at least in Chennai. I don't know of. Sundarbans definitely is happening. Orissa, it's happening. So more along the eastern coast is something that I'm aware of. There are the state governments, respective state governments are also proactively looking at what ways they can do to see that you can at least shield the coastal communities. I can just tell from what I know from in the state of Tamil Nadu. So they are more moving more towards having these bioshields, as I told. So they have a specific agency that they have. So this is again a wetlands mission, in addition to a state wetlands mission or an authority. They also have an agency called the Blue Carbon Agency, which is primarily looking at mangrove seagrass restoration. So this is actually looked at in reducing climate related disasters, or at least reducing the impact of it. So that's something that started over the last 2 3 years. And hopefully, I think mangroves, as a matter of fact, take a lot of time to grow. They need a lot of care. So hopefully, I think in the next decade, we are more better prepared towards these climate related disasters.
Very nice. Thank you. Thank you, Prathna. I have a very general question. So you carry a testing kit for water quality monitoring and implementing projects. So being IEEE as a largest community for engineers and technologists, do you see any way where technology devices like sensors for water quality monitoring, or when you're deploying sensors, could be improved for the future so that the work can be done efficiently?
Thanks, Dayalan. Yeah. So, as a matter of fact, even for the study today, we are actually carrying, we call this the multi parameter probe, which is, I mean, just sensors, multiple sensors. And it's a single device. I would definitely say, I mean, I have been for my PhD, as well as for at least for one of my postdocs, which was more than 10 years back. I still remember how tedious it was to water quality test whenever we went for site visits. So things have definitely changed. So it's after a break, I'm starting to carry these water quality kits. So those days it was really bulky, and testing wasn't as easy as it is now. So definitely improvements are there. I wouldn't say there was a challenge or something that we experienced on site. So the probes that we have are I think good enough. So definitely an improvement compared to what it was a few years back.
Thank you. So, as a last note, I think from our general chair, Charlie, he says, thank you very much for the interesting talk on how India is moving forward, resilience and adaptation. And it was very, very thought-provoking. And it's a contrast in how things are done in North America. And thank you, Prathna, for the wonderful talk, and very nice to connect with you.
Thanks, Katie, and thanks, Ellen.
All right. Kathy, Charlie, do you have any? This is the last talk of the day. Do we have any message for the attendees or for the tomorrow?
No